Hi, it's Carly McAvoy. I'm talking tonight about finding a z-score when you're given a probability or when you're given an area, which is essentially the same problem, or a percentile, which is also the same thing. Remember, a percentile, 95th percentile, means that 95% of the values lie below and 5% lie above. And so when you want to know the z-score for that, you're looking for something up here at the 95th, splitting the 95 from the 5%. And so these are standard normal deviation distributions, excuse me. So we're going to use 0 and 1 here. I'm going to use the TI-36X PRO to do this. I'm going to push second function data. I'm going to go 1 to the right. Now before we were trying to find the area under the curve, but now we know that area. That area is 0.95. That's what the 95th percentile tells us. So I know the area. I want to find the z-score, so I'm going to go down to inverse normal. Hit enter, and then the area that I'm given is 0.95. You can put 0.95 as well. The mean is 0. Standard deviation is 1. I'm going to scroll right down to calculate and then hit enter. And that's going to give me the value, my z-score value. And we should have expected it to be positive because this is 0 and this is 1 and this is 2. And you can see that we can expect it to be between 1 and 2. So for z-scores, we typically use 2 decimal places after. So we would say that this z-score is 1.64. We can see that on our calculator that it's 1.64. Okay, so for the next one it says find the z-score for the bottom 2.5% and the upper 2.5%. So if I was to look at those pictures, this is what I'd be looking at. Here is the bottom 2.5% and here is the upper 2.5%, and we want to find the z-scores for both of those. So on certain mechanisms, it's easier to do than others. Remember this calculator, we typically look at what's happening to the left of that, but for these z-scores, we don't have the ability just to say, oh, we think of this as being to the right. So we'll do a little more work for this, but not a lot. So we're going to start off and do second function data and go to the right. Now this where it's to the left, those are the kind that our calculator does really nicely. So we're going to go down to inverse normal, click on enter, and I know that we're talking about 2.5%. And if I move that decimal point 2 places to the right, we're talking about 0.25 as the area that we're interested in. So 0.025. And then enter, 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 enter. And that is a very famous value, negative 1.96. We can see it would be negative because here we have 0, and here we have negative 1, and here we have negative 2. We're not quite to negative 2, but we can see that it's going to be negative 1.96. Now the nice thing about standardized normal distributions is on this case, if we're talking about 2.5% to the left and 2.5% to the right, I know right away this value must be the inverse of the other one, or the positive 1.96. But what if you didn't want to find the left one, you just wanted to find the right one? Well, in that case, we can see that the answer is that one. In this case, what we would do is say, well, I really know that my calculator likes to think of everything to the left. So I could take 1 minus 0.025. What is that? 0.975? And then I can enter 0.975 into my calculator because then that tells it, well, I know that 0.25 is to the right, but 0.975 is to the left. So that's how you can kind of trick your calculator into giving it what you want. Second function data, go to the right, go down to inverse normal, and now instead of putting the 0.025 and having it think about it to the left, you're going to put the 0.975 and get that to calculate, and you can see that that comes out to be 1.96. So that works out nicely. Okay, the next one we're looking at is probability that z is greater than a equals 0.7224, and the probability that Z is less than B equals 0.0192. So in both of these cases, we're given the area and we want to find the Z-score. So we're going to use inverse normal. But also, what do the pictures look like for these? It's really important that you can picture what we're looking at. And why would people be asking this? Maybe somebody would say, oh, I want to do something for everybody who's at least at a certain point on the scale. Like maybe everybody who's got a negative 1/2 Z-score or above, I want to do something for them. Or anybody who's really down here, if you're at school and you see somebody testing really low, you say these are the students that we want to get extra help to or something. So you can see here if A is here, and this is 0.7227, we know because it's more than 50% that this is 0. Anything to the right, from 0 to the right, would be 50%. But we're further back. We're going to have more than 50%. And over here, we have this really little tiny bit right here. But you can see that both of our values, when we find them, have to be negative because they're to the left, of 0. So let's put that in and see what we get. Second function data, 1 to the right and down to inverse normal. And then our area is 0.7224. And if I scroll down and calculate, I get, what did I just do? So remember, when it goes to the right, it's going to tell you the area to the left, right? When we put that in, it assumes that that's the area to the right. And you see how it gave me a positive? This is a good mistake to make because people make this mistake a lot and they don't stop to think about it. Notice that my value should be to the left, not the right. So I know my value should be negative 0.59, not positive, because I can see right here the starting point is to the left of 0. Does that make sense? So I know that it has to be a negative 0.59. And I just didn't do that on my calculator. The way I could have done was taking 1 minus this and enter that value in to give me the correct sign. But I also can just use my brain when I get those to say, wait a minute, a positive value does not make sense here because my starting point is here, and that's definitely to the left of 0. Okay, so same thing over here. My starting point is going to be negative, but also notice we're going to the left. And those are the ones the calculator does nicely, so I don't have to worry about that. Over to distribute and down to inverse normal. And then my area here is 0.0192. I went too far. 0.0192. I'm really having a hard time operating the calculator all of a sudden. And then hit enter, and that gives me negative 2.07. And that should make sense. This is -1, this is -2, and a little bit past that, and that's how I get the negative 2.07. So your calculator does really well with the stuff to the left. But if you're going to the right, you either need to do the subtraction like I did in the previous problem up here so that you can get the actual value, or you can do it as is, but you need to think about the signs yourself so that you're getting those signs correct. All right, have a fantastic day. We'll see you next time.